Okay, welcome to Planet Geography. Today we're dealing with tectonic plate boundaries. Here is my very to scale world map. Okay, now this is the outer layer of the Earth, which we call the crust. Now the crust is broken down into tectonic plates. Okay, these tectonic plates form the entire surface of the Earth. You can't be on Earth's surface without being on a tectonic plate. Okay? Now these tectonic plates are moving. Now why did they move? They move because of convection currents in the Earth's crust. In the Earth's mantle. Now, these tectonic plates, they are moving. They are moving in different directions and at different speeds. So, if they are all moving at different directions, you're going to see that they're going to have different types of tectonic plate boundary. So, what I want you to take away from this is that the Earth's crust is broken up into tectonic plates, and these tectonic plates are moving. I'm now going to flash up a actual world example of the tectonic plates that exist in this world. And what you can see here on this map are lots of different examples of tectonic plate boundaries, but I'm going to focus in on three. Now, there are three different types of tectonic plate boundary. We're going to call them in this video convergent, divergent, and conservative. Now, the convergent example I'm using here is the Naztec plate and the South American plate. The example for divergent that I'm going to use is up in Iceland. It's the North American plate and the Eurasian plate moving apart. And the final one is the conservative plate, where we're going to look at the west coast of America, California, and we're going to look at the San Andreas fault line. Okay, so those are the three types. Let's get into them, because the first thing we need to know is the different types of tectonic plates. Okay, so there are three different types of tectonic plate boundary, and different specs call them different things. We're going to go with convergent, divergent, and conservative. That is what they are called in the LXL specs. They can also appear as destructive, constructive, and transform. So you need to know which one is relevant to you. Okay? So, in a convergent plate boundary, you should know from your tier 2 words that converge means to come together. A group of kids converged after the fire alarm. Okay? Means to come together. So converging, I always kind of think about it as a kind of a car crash, really. Big, powerful things, two cars going in opposite directions crash into each other. Okay? The next is divergent. Divergent is the opposite. If the bus is on diversion, it's going away from where you want it to go. Okay? So it means kind of, again, diverge. You could say there's a divergence of opinion as well. When two people have a different opinion, it means to be traveling away from each other. The final one is conservative. Now, a conservative plate boundary, there's no real metaphors here that I have for this one. It kind of means to pass side by side. Okay? The real big thing about conservative plate boundaries is they only produce earthquakes. They don't produce volcanoes. Okay, the classic example we'll be using in this video is the San Andreas fault in California. Again, there's no volcanoes in California, but there definitely are earthquakes. So these are the three kind of different tectonic plate boundaries. Wherever you find a tectonic plate boundary, so the border between two tectonic plates, you are going to find it to be one of these. Okay, and this is where we find tectonic events. Now, most of you watching this video, myself included, have never experienced a tectonic event. And that's because we live in England. It's not on a tectonic plate boundary. And therefore we don't get earthquakes, we don't get volcanoes. Okay, now what you do need to know is the nature of these is very different. And we will go into them in more detail, but very powerful but very rare earthquakes and volcanoes. Very frequent, so very common earthquakes and volcanoes. And then here, powerful earthquakes, not as powerful as a destructive plate boundary, a convergent plate boundary, but still very significant. Okay, now for this, to understand all of this, you're going to need to know that there are two different types of tectonic plate boundary. Okay, this will become kind of key if you're going to understand as we progress through the video. Now the first one, which I will do in red, is a continental plate. The second one, in which all of the videos I will be doing it in blue, is oceanic. Okay, continental plate, oceanic plate. Now, the thing that you really need to know more than anything is that the continental plate is less dense. Okay? The oceanic plate is more dense. You should really know these expressions from science about density. It essentially means that one's heavier. Okay? And the continental plate is lighter. These tend to be older plates versus the oceanic plate, which are younger. When we say younger, they're still 200 million years old. I mean, humans are only 200,000 years old, so they're incredibly ancient, but they are younger. But the real big thing you need to know is that the oceanic plate is more dense, the continental plate is less dense, and so this one gets pushed down. Okay, right. Now we can get stuck in. Let's start with convergent plate boundaries. So we'll jump into that. Okay, so let's deal with the most complicated first in convergent plate boundaries. Remember, blue is oceanic and red is continental. So in a convergent plate boundaries, the plates are going in opposite directions. And so here is our oceanic plate. And here is our continental plate. So we have our two tectonic plates. Remember, the oceanic plate is more dense. What does that mean? It means it's heavier. Okay? The continental plate is older and lighter. Okay? So this is a heavier plate. So when the two meet and they push against each other, as we see in a convergent plate boundary, one is pushed down. It's going to be the heavier oceanic plate. So it gets pushed downwards, like so. And this is called subduction. Now, if you're going to understand convergent plate boundaries, you need to understand subduction. It simply means one plate is pushed beneath the other. In this case, it's the oceanic plate. So this can kind of cause a few things to happen. So first of all, we need to understand why this is happening though. And this is happening, the movement of tectonic plates, you should know this. I've covered it in a separate video if you'd like to understand it a little bit more. This is happening because of a process that is taking place inside the mantle. Okay, this is convection currents. Yep. And this is providing our tectonic plates the energy to do this. Think about the energy required to move a continent. Okay, absolutely huge. Okay, but when it does, it pushes down, and this isn't a lesson on volcanoes. But what can tend to happen is subduction can cause pressure to build up in the mantle, forming a volcano. Okay? But the main thing to know about a convergent plate boundary is the fact that they are going in opposite directions to each other, and the oceanic plate is subducted because it is more dense and less dense. Okay? Well, what are the effects of this? What are the effects of this? Well, the effects are threefold. In this type of tectonic plate boundary, you are going to experience volcanoes. You are going to experience earthquakes. And finally, you are going to experience tsunamis. But what is the nature of them? What are these volcanoes like? You have to understand, again, this is where it's kind of kind to us, it helps us. In convergent plate boundaries, they're kind of all the same. They are powerful. So they're going to be highly explosive volcanoes, incredibly high magnitude earthquakes, and devastating tsunamis. And they are going to be rare. Well, what does rare mean? Rare kind of means it doesn't happen very often. And this is why they can be so deadly, is that people start to live near the volcano because they don't happen very often. Okay, they can be over 100 years, so everybody's passed away that remembers the last event. And then boom, suddenly you get these huge powerful events. Okay, that is a convergent plate boundary. We're now going to look at divergent. Just before we do move on, the example that I would use for this is the Nazca Plate and the South American Plate. Here's an image of it, and that's a classic example of a convergent plate boundary. Okay, so let's deal with divergent plate boundaries. So, as we discussed in our intro video, divergent means to be moving away. Okay, so we're going to give you an example of two oceanic plates that are moving in opposite directions. Here is the boundary between the two. Okay, so this is where we expect tectonic activity to take place. They are the same density because they are the same type of plate, oceanic, and they are moving in these directions. Again, same as before, they are responding to patterns in the mantle from our convection currents. So, in its essence, that's kind of exactly what they are. Two oceanic plates moving in opposite directions and caused by convection currents. So then what happens? Well, okay, what's the effect of this? What we see is up from the mantle rises magma. It rises until it reaches our ocean floor and forms new ocean floor, becomes lava and forms. In fact, I'm going to draw this in brown to show you that new land is being created. New ocean floor. Okay, so this is a classic example of the Mid-Atlantic Ridge. Okay, it runs all the way between the two plates, which are the Eurasian plate and the North American plate. Yep, and if you look at this example that I'm going to put up on the screen as an image, this is really how Iceland formed. Lava was added and added to the ocean floor until it rose above sea level, creating new land. Okay, that's Iceland. That's exactly what Iceland is. When you are in Iceland, you are standing on a tectonic plate boundary. You are standing on a divergent volcano, or shield volcano that's formed this entire nation. Okay, so what is it like to live on a divergent plate boundary in terms of the events that we see? Well, again, they're very helpful because there are some similarities. Yes, we experience volcanoes, but as you can see from the image that I put up, people are very happy stood next to them because they are very weak. Okay, they are not powerful like those experienced on convergent plate boundaries. Yes, we do get earthquakes again, but again, then you're not living in fear of earthquakes because they are weak. Tsunamis we don't really experience them. Okay, they don't take place. They may take place, but again, I think you can proceed in your GCSEs by saying they don't occur in this situation. Add to this, well, what are they like? They're weak, but they're also frequent, which is the opposite of rare. They are frequent. So again, if you're living in Iceland, there may be an earthquake whilst you're at a restaurant, and all that happens is the table shakes a tiny little bit and stops. And you look around the restaurant and nobody even cares. It's such a frequent and common thing that people don't even talk about it, okay? So this is a divergent plate boundary, all right? The absolute keys that you take away from this are two tectonic plates moving away from each other, magma rising up from the mantle to create new ocean floor. Yes, there are volcanoes, and yes, there are earthquakes, but they are weak and frequent. Okay, hope that helps. Let's jump into the final one, which is conservative. Okay, so let's deal with the last type of tectonic plate boundary, conservative. Now, with a conservative plate boundary, what you see is there are two tectonic plates moving side by side. Now, in the example I'm about to give you, they are moving in opposite directions, and that's just because the example I will use later, that is true, okay? But equally, it could be two tectonic plates moving in the same direction but at different speeds, okay? We're not really interested in density here because there's no subduction, because what happens is as these two plates move past each other, there's lots of friction and tension and pressure built up, and then it slips, and we experience the big hazard on a conservative plate boundary as earthquakes. Now, we don't get volcanoes, and we tend to not get tsunamis either. That's the very basic understanding of it. Two different tectonic plates moving in opposite directions or the same direction at different speeds, and it leads to, I'm going to say significant. They're not as powerful as earthquakes on a convergent plate boundary, but they can still be very, very powerful and cause a lot of damage. The example, if you take a look at this image, the example I've put up is of LA. Take a look at the impacts, the primary and secondary effects. And what you will see is the San Andreas fault or plate boundary in effect, okay? Now, if you've played Grand Theft Auto, which I'm sure you haven't because it's an 18, the town and the city is based on LA is called the San Andreas. And in the story mode, which I'm sure you have no idea of, you get earthquakes built into the story modes. So when we think about LA, it's very much part of the identity of the city. Okay, so that is the example I would use. And the plates we're talking about are the North American plate. And that is traveling in a northwards direction. And then the Pacific plate, which is an oceanic plate moving southwards. That is a conservative boundary, and once again, I'll just remind you that there are no volcanoes because there is no subduction, okay? I like this one. Often I'd encourage kids to write about it in their exam. I think it's the easiest one to get the marks in, and yeah. Okay, I hope that helps.